Welcome to the kitchen. It's a familiar space, but for Prithvi, it's also the perfect place to observe how things change. He pulls a cold water bottle from the fridge and sets it on the counter. After a few minutes, he touches it and realizes it isn't cold anymore. We're constantly using our five senses, sight, smell, touch, hearing, and taste, to detect these shifts. Prithvi can see and smell that a banana on the counter has more brown spots and a much stronger scent than it did yesterday. These transitions happen everywhere. A small bud on a rose plant opens into a flower, or a handful of hard corn kernels pops into fluffy white snacks on the stove. Everything around us is in a state of change. By looking at these moments closely, we can begin to sort them into distinct scientific categories. The first category is physical changes. If Prithvi crushes chalk into powder or blows air into a rubber balloon, the shape or state changes, like solid ice melting into liquid water, but no new substance is created. It's still chalk, still rubber. Now consider what happens if Prithvi takes a straw and breathes out into a glass of clear lime water. The liquid turns milky white. That cloudiness indicates a brand new substance, calcium carbonate, has formed and settled at the bottom. Because the starting material has turned into something else, we call this a chemical change. We see this same chemistry when wood burns. A process called combustion uses oxygen to react with the wood, producing heat, light, and ash. Nature even uses this in living things. These fireflies glowing in the dark are the result of bioluminescence, a chemical change producing light without heat. Whether you are crushing chalk or watching an insect glow, the test is always the same. Is there a brand new material that wasn't there before? We can also group these events by whether they can be undone. Put melted ice back in the freezer, you get solid ice. This is a reversible change. Other changes only go one way. Once he chops his vegetables or pops his corn, he can never get their original forms back. These are irreversible. We also categorize things based on how they affect us. Processes that are useful, like turning milk into curd or cooking a meal, are called desirable changes. Changes that cause damage, like iron nails rusting and flaking away over time, are usually considered undesirable. However, desirability depends on the context. If fresh food decays and rots inside a refrigerator, that's a problem. But if he tosses those vegetable peels into a clay pot, that decay becomes a highly desirable change. It creates compost that he can use to grow new flowers. Understanding a change means looking at the chemistry, seeing if it can be reversed, and checking if it serves a helpful purpose in the environment. These same rules apply far beyond the kitchen. At the base of mountains, you can see massive heaps of sand, soil, and stones that have been broken down from the peaks above. This is weathering. When water freezes inside the cracks of a rock, it expands, physically forcing the stone to split. Over years, these physical changes break mountains into sediments. Weathering can also be chemical. When minerals in a rock react with water and air, they can produce entirely new materials, like this reddish-brown layer of iron oxide. We can look at any transformation and ask, is it physical or chemical? Reversible or irreversible? Desirable or undesirable? The next time you watch a piece of dough cook on a stove or see a giant rock crumble into dust, use your senses to see which of these patterns you can spot.